Welcome back to section 4 of chapter 1. Here's where you're probably a little bit more comfortable because we're going to be doing more math and stuff that you do a lot of in Algebra 1. And so this is what people tend to remember the most. However, there are a couple misconceptions that some people still have troubles with. And so we're going to focus more on that. But we're going to be simplifying algebraic expressions. We have a learning target for today. I can simplify and evaluate algebraic expressions. I mean, if that's not descriptive, I don't know what is. So, first thing, let's look at the definition of math. Now, if you think of the definition of math and you ask different people, you're going to get different definitions. In fact, your definition might be different than mine. It might involve some four-letter words that I don't need you to be saying in class. My definition of math is it's the language of the universe. That's what everything that builds up the universe is written. It's the foundation of it. From math, you put it together into literature, and that's where you get the sciences. But math is the foundational language of the universe. And so it is a language. And because of that, we're going to be translating between math and English. And math has verbs, just like English does. Our verbs look different. They're like the plus symbol is a verb. It means we're going to add. And then subtraction, multiplication, division, all those things are verbs. And then with it, our grammar, we have what's called the order of operations. We have a great acronym that goes with this, and it might be different than an acronym that you have seen before. The acronym for order of operations is PEMA. We don't, you may have seen PEMDAS in the past. We don't use that, and I'll show us why when we get there. But the P, just like always, stands for parentheses. E stands for exponents. I have to tell you, I've been looking for a synonym for exponents that begins with a U, so this acronym could be PUMA, but I can't find one. And a synonym, for those of you who aren't English people, a synonym is a word you use when you don't know how to spell the other word. M, we multiply and divide from left to right. This is all the same step. That's why it's not separated out into two. It's the same step. We're going to multiply and divide from left to right. We'll see an example of this and why it makes a difference in a minute. And then the same thing with A, we're going to add and subtract from left to right in the same step. And so, if we look at some quick examples of this, let's look at an addition and subtraction one. 9 minus 3 plus 2. All right, do that one really quick. Are you done? All right. So, 9 minus 3 plus 2. People are like, well, you add first, so that's 3 plus 2 is 5. No, you have to subtract. And a way to fix that issue, if you're one of those people having that struggle, which I've known some, and even in Honors Algebra 2, and this fixes that problem. Don't think of that as 9 minus 3. That's 9 plus negative 3. See, now we have an addition problem, and all those properties, commutative property, the associative property, all of those are now in play. Notice that the other day we did not have properties of subtraction. Do you know why that is, other than they don't work? It's because subtraction does not exist. Your teachers have been lying to you for the past number of years. There is no such thing as subtraction. We are simply just adding a negative number. So 9 plus negative 3 is 6, plus 2 is 8. And so that's definitely a different answer than if you would have tried to add the 3 and 2 together to get 5, and then 9 minus 5 is 4. No, it's 8, because this isn't 3 plus 2. It's negative 3 plus 2, which is negative 1. 9 plus negative 1 is, again, 8. It works the same with multiplication and division. Usually we don't use the x for multiplication anymore, but for this problem, we are. So 9 divided by 3 times 2, when people use the old PEMDAS system, like, okay, multiply 3 times 2 is 6. 9 divided by 6 is 3 halves. No. Multiplication and division are the same thing. Just like subtraction, there's no such thing as division. We are just multiplying by the reciprocal. So this is 9 times 1/3 times 2. Now it's commutative, and we can move it around. And so 9 times 1/3 is 3 times 2 is 6. So the addition and multiplication, that left to right thing with the division subtraction, that is one of those things that people mess up on. Even though they know what they're doing, that's something that gets people. We're going to have two different types of directions here. One of them will be evaluate, the other will be simplify. We'll look at evaluate first, and evaluate has two steps. We're going to substitute, then we're going to simplify. If we look at a problem, we'll have something like 6c minus 3c squared plus d cubed, but that's not all it'll tell us. It'll say, hey, and c equals 5, d equals 3. If I just gave you this problem and told you to figure it out, chances are the first thing you'd do is you'd take this c and this d and you'd plug them in. That's exactly what you need to do. That's substituting. So we're going to take our c and our d, and we're going to plug it into c and d. So we have 6 times c, which is 5, minus 3 times 5 squared plus 3 cubed. Notice I put them in parentheses. It doesn't always make that much of a difference. Like here, this 3 doesn't need to be in parentheses, but it's a good habit to be in so that we're doing things in the correct order. Like this 5 is still going to be squared. It's not going to be multiplication first. And then we simplify. That would be order of operations. First thing, parentheses. There's nothing going on inside of the parentheses, just numbers. So then we can deal with exponents. 5 squared is 25. And 3 cubed? No, it's not 9. How many of you thought 9? 3 cubed is 27. So we have 6 times 5 minus 3 times 25 plus 27. Now we can do the multiplication. 6 times 5 we could have done the last step because there were no exponents affecting that. But 6 times 5 is 30. 3 times 25 is 75. And the 27 is just going to hang out. 30 minus 75 plus 27 is negative 18. And so that would be the evaluation. We end up with a number. Now, in all of these questions that we have today, we are dealing with expressions. Notice I don't have an equal sign in the problem, aside from here where it's defining the variables. There's no equal sign. I don't magically get an equal sign. And when we work with equations, we need to not magically lose our equal sign. Those are important. The answer here is just negative 18. It's not x equals negative 18. It's just negative 18. All right, let's look at another one of these. Here we only have one variable, but 2g minus 1 squared minus 2g plus g squared. And let's let g equal 3. If you want, you can plug this, pause, plug this in, and try it out really quick. If you're thinking, yeah, let's see it first, I have another one for you to try after this. So if you want to pause it, do it now. All right. So first step, we plug it in. 2 times 3 minus 1 squared minus 2 times 3 plus 3 squared. Again, notice all of mine are in parentheses. It just makes it so I don't do something stupid. 2 times 3 is 6, minus 1 is 5, because we're going to do the parentheses first. And yes, I do believe that you can get from 2 times 3 minus 1 to 5 in just one step. You don't have to show me, well, 6 minus 1 and then 5. In fact, you could probably do 2 times 3 minus 1 is 5 squared equals 25 in one step. I wouldn't do more than that in one step, though. For us, we're just going to go 2 times 3 minus 1 is 5 to get 5 squared. Then 2 times 3 is 6, so we'll have minus 6. 3 squared is 9. So then 5 squared minus 6 plus 9, that's 25 minus 6 plus 9. 25 minus 6 is 19, plus 9 is 28. So if you paused it and did it on your own, did you get 28? Yes? Good. If not, did you see what you did wrong? It's important. Don't make a mistake unless you're willing to learn from it. All right, so now here's one to try. y squared minus 2xy squared minus x, and then x equals 2, y equals 3. So go ahead, pause this, do that real quick, and then push play when you're ready to come back. How'd that work out for you? Do you think you got it? So first step, we're going to plug them in. Y is 3, so we get 3 squared, another 3 squared. X is 2, so we have a 2 there and a 2 there. First step is parentheses, but there's nothing going on inside of our parentheses. So next, we do exponents. 3 squared will be 9. This 3 squared will also be 9. And the minus 2 is just hanging out. So you have 9 minus 2 times 2 times 9 minus 2. Multiplication, 2 times 2 times 9. 2 times 2 is 4 times 9 is 36. 9 minus 36 minus 2 is negative 29. Is that what you got when you did it? Did you do 36 minus 2 is 34 and then do 9 minus 34? Because that could be a mistake that people make. I see it all the time. Don't do that. The answer is negative 29. And so that's evaluating. We substitute and then we simplify. And our answer is a number. Now for simplifying, I know evaluating we substituted and then simplifying. This simplifies when we still have variables in our expression. And the secret to simplifying is combine like terms. That's all simplifying is. So if we have something like negative x minus 3y plus 4x minus 9y plus 2, we want to combine our like terms. So first thing we need to do is find our like terms. We have a negative x here, and we have a plus 4x here. Those are like terms. A like term has to have the same variable structure, same variables with the same exponents. Here we have a minus 3y. Oh, negative x plus 4x is 3x. And then we have negative 3y and a negative 9y. Notice when I'm circling these, I'm including the negative because when I see this, I see 4x plus negative 9y because that negative has to be stuck with that negative 9y. Same thing with the negative 3y. Negative 3y plus negative 9y is negative 12y, and then the plus 2 had nothing to combine with, it just sits there on the end. And so that's what simplifying is, combining like terms. Sometimes we'll have parentheses here. So first thing we do is in parentheses. 3n plus 2n. You can't combine those. So then you have to distribute to get rid of the parentheses. If this was an addition, there's really nothing to distribute because it's just 1. However, with that subtraction, we have to distribute that negative to both pieces on the inside of the parentheses. So we'll end up with 5 minus 3m minus 2n. Now we can combine our like terms, which in this case there are no like terms, so this is done. It's simplified because there are no parentheses and there are no like terms that haven't been combined. So that one's super easy, although you might be thinking, well, this one was really easy too. Yeah, simplifying isn't necessarily hard. So let's try one. And by let's, I mean you're going to try one. So here we have negative 4 times negative a plus 3b minus 3 times a minus 5b. So this one you're going to need to distribute and you're going to need to combine like terms. So go ahead and pause the video and then come back when you're ready to look at this problem. How do you think you did? You should have 2 terms left, one with a's, one with b's. So first step, we can look at this side of it. This negative 4 needs to distribute to both pieces. Negative 4 times negative a is 4a. Negative 4 times 3b is going to be negative 12b. So we have 4a minus 12b. Now we can look at this one. We're going to have to take this negative 3 and distribute it to both pieces. Negative 3 times a is minus 3a. Negative 3 times negative 5b is positive 15b. So we have minus 3a plus 15b, and now we can combine our like terms. We have 4a minus 3a is 1a. Negative 12b plus 15b is 3b. So we have a plus 3b is the simplification of this. So evaluation questions, you end up with a number. Simplification, you'll still have variables in it. And that's section 4. Again, it's a lot of stuff that, if you remember stuff from algebra, this is probably some of the stuff you remember. And lots of using the properties that we saw a couple sections ago. So I will see you later.